In the section M.2.4, we're going to calculate geometric quantities. This is where you're going to learn your geometry. If you've never had geometry before, do not let that scare you. If you know your basic shapes and can use formulas, then you'll be fine. We need to demonstrate knowledge of area as a square measure, demonstrate knowledge of circumference as the perimeter around a curved shape, understand the concepts of length, area, and surface area, calculate areas of a regular shape by finding the sum of the areas of sections, and calculate linear measures by finding the sums of the lengths of sections. Now, all this comes down to, can you find perimeter, which is the distance around an object, or area, which is the amount of surface covered by an object. So we only really need to know about perimeter and area until we start talking about circles, which is what this paragraph here is going to talk about. Now, before we get to this paragraph, let's go back up into the previous paragraph, and on the TEAS, you'll need to be able to calculate length and areas of shapes, both regular, which would be your basic shapes, and irregular, which would be shapes where you might have two different shapes combined together, such as this little example right here, using various units. Now, the units of length that we've already talked about in different sections have been inches, feet, yards, miles, centimeters, meters, and kilometers. We've already talked about all these different types of units of measure in previous sections. Now, both straight and curved shapes possess length, but it's kind of hard to measure a curved shape with a ruler or a tape measure. So we got to figure out a different way to do those. Curved shapes include arcs or entire circles. And the length of the distance around a circle is called circumference instead of perimeter. And it's calculated by using the formula C equals 2 pi r, where pi is approximately 3.14 and r is the radius of the circle. So make sure you understand those two. When you're using your calculation, just automatically use 3.14 unless you're told otherwise. Now, the length of an arc of part of a circle can be found by using this formula. The circumference equals 2 pi r, then multiplying by this fraction. Since we're only wanting to know part of a circle and not the whole circle, we have to be able to figure out how much this circumference part is right here. That's just for this particular arc. This is where this little formula part comes in here. You've got your degrees for the angle. We know there's 360 degrees in a full circle, so we take the part of the angle over the full circle. We're going to multiply that by circumference to find just the length of this arc. Now, in this example that I wrote on the lecture notes, and make sure you do print those out so you can see it, is we have a arc of a circle. We know its degrees, and we know the radius. Now, if you go from the center of a circle to any point on the outside of the circle, that's still the radius. That's why both of these are called r's. But we only need one of them, and the other one is just to show how far your angle is. So in my particular example, I have an arc of a circle with a radius of 6 inches and an angle measure of 72 degrees. So I'll plug those numbers into the formula above. I have 72 degrees over 360 degrees times 2 pi r. Already plugged in the numbers, 3.14, plugged in the number 6 for the radius. I do my calculations, so I get a final total of 7.536 inches. So the length of this particular arc with these qualifications or these numbers will be about 7.536 inches. Now, if I was talking about the whole circle, then I would just use the 2 pi r part. But since I'm talking about part of it, or an arc, I have to use this particular formula. Now, before we go any further, let's go over here and look at our key terms. We have arc, which we just talked about. We have the area. It's the amount of space inside a two-dimensional boundary. We have our circumference. It's the length around a circle. So if I want to do the full circle, I can do the circumference. A regular shape. This is an irregular shape. It's not a rectangle. It's not a square. It's not one of your basic geometric shapes that hopefully you're familiar with. The length is the measure from end to end. So from this corner of this particular side of this particular object to the other side is 6 centimeters. That's what they call the length. The linear units is a unit used to measure length, as we said before. Any of the previous units that we've talked about as far as length we could use. A perimeter is the distance around a two-dimensional shape. Circumference is for circles. Perimeter is for things with square sides or straight sides. Square units is the area of a square with sides that measure 1 unit, and you'll learn later on in the formula section where you actually determine what a square unit is. A subtend is a form an angle at a particular point on an arc. So when I did my example, mine was 72 degrees. Other than that, you won't really have to know that term. Just know that it's the same thing as an angle. The sum is a total of 2 or more values. Well, we learned that when we was talking about addition back in a previous section. And our surface area is the total area of a 3-dimensional object's surface. So if instead of having just a flat 2-dimension circle, I had like a basketball, which is a 3-dimensional circle, or I had a cube, which is a 3-dimensional square, or a rectangular box, like a shoe box or an ice cream box, which would be a 3-dimensional rectangle, we could find the surface area. They have length, width, and height. But as far as the TEAS test, you only have to work with 2-dimensional shapes, so you don't really have to worry about the surface area part. Now let's go down and look at our 2 irregular shaped objects they've got here. This one looks like it may be a rectangle, and then another rectangle up under it, but it's not just one rectangle, it's 2. So if I broke them up, then I would have 2 rectangles. But you might need to find the length around a shape which is known as perimeter. So in this particular example, as you will notice, if this is maybe a room in your house, and then you got a little indentation out here that's not, maybe a closet that's not part of the room, we have the lengths of all the sides except for this one and this one. So we would have to be able to figure out the length of those particular sides if we was going to find the perimeter. Now the way you would do it is you'd see that this whole length here should be the same thing as from here to here, and if I extend it on out to right here. So these two sides, side here and this side, has to equal. So to find this little part, I would go 6 minus 3 will leave me 3 centimeters for this part. Well, that takes care of this side here, which is now the same as this side. But to find this little side here, I know that from here to here is 4, from here to here is 2, so from here to here would have to be the rest. So 4 minus 2 will be, this is now 2. Well, if this side is 2, then this right here is 2. So now I've determined all my sides, and all I would need to do is just add up those numbers to get the perimeter. Now in this particular shape here with all square sides, it's a little bit easier. What if I get down to here and do one of these? As you can see, this particular shape has both a curved part and straight line parts. So if we broke this up, we might say we got a rectangle here, and then this is part of a circle. It's half of a circle. We call this the semicircle. So in this particular part, to find the length of the semicircle can be calculated by finding half of the circumference, or just pi over r. So when you have a semicircle, which is part of a circle, you're going to use the circumference formula of pi times r instead of 2 pi r. 2 pi r is for the whole circle. We only want half of it, so we're just going to use pi r. And as you can see from this example, they worked that out. Then they found out the perimeter of here to here. Well, this side is a certain amount. This side has to be the same amount. This side is that length, which also makes the diameter of the semicircle the same amount, because you can kind of see this side and here has to equal. Now this is an example, the closest I can come to be, this would be the foul line for a basketball, on a basketball court. It's also called a Norman window if you have it as a window. And there's an example of a Norman window in one of your TEAS questions. So just make sure you understand. A Norman window looks like this, also, which is the foul line of a basketball court. Has a semicircle top and then a rectangular bottom. Now, one thing I haven't mentioned, which is very important, is that when you're talking about area, is how much surface space something takes up. So area units include square inches, square feet, square yards, square miles, and square meters, etc. So when you're doing area, you have to have square units to measure. But when you're going back up here and doing just perimeter or circumference, it's just whatever units to measure it. So make sure when you're working on the TEAS test, they don't give you a perimeter problem with a square unit answer. That will be wrong. If they give you an area problem and just give you the basic units of measure without it being squared, that is also wrong. Part of the answer has to be square units if you're talking area or just basic units of measure if you're talking perimeter and circumference. So be careful on that when you're doing those two parts. Now, one thing you need to be familiar with, and one of the handouts that I gave you on your on last Tuesday was to watch these formulas. You have your basic square, rectangle, triangle, parallelogram, trapezoid, circles, and rhombuses. So if you basically know your area formulas, they gave you an example here, so you can look at these examples and see how to do that. Then you should be able to do well on this test. And in the earlier example, we found the perimeter around this basketball foul line. We could also find the area of that by just breaking it up into a combination of formulas. In this particular example, we'd have the rectangle, then we would have the semicircle. So find the area of the rectangle, which is length times width, or 9 times 6, or 54 square feet. Then for the semicircle, we've got to find the area of the circle with a 3-foot radius, then divided by 2, which is divided by 2. Since we only want semicircle, once we get that, we're going to have this amount. So our total will be this total amount. Hopefully you can read the numbers better in your book. Now here's another example of an irregular shape. Basically just what you just did in your book was you found the perimeter of your regular shape by finding the lengths of your missing sides. I have this side missing and I have this side missing. So this particular part would be 18 minus the 10. This little particular part is going to be 8 minus the 5. Found them the same way as I did on the previous example in your book. Now what we didn't do in your book was we didn't find the area. What you would do on this particular irregular shape would be the same things you did on that Norman window or the basketball foul line that's in your book was. I broke it up into 2 different rectangles. I have the blue part is the size of 8 times 10. Then the red part is going to be 5 times whatever this is. I've already said that's 8. So I got 5 times 8. So I get 40 square feet, 80 square feet from the first bigger rectangle. Add them together, I get 120 square feet. So on these two particular examples here, I found the perimeter first, then the area. Now in your practice problems, you may have where you have a combination of 2 different shapes. So as you're doing your problems, just make sure that if you have 2 different shapes involved in a problem, just work them one at a time. So we have a square with sides of 12 inches, has the largest possible circle drawn inside the square. And now we want to find the area of the box not covered by the square, the part that is in gray. So the circle covers everything that's in the red. The box covers everything that's in gray, including what's behind the circle. But I want to find out which is not covered. So our solution is we have 2 different shapes to find the areas for. Now in the square, that's not that difficult. It's length times width, or length squared, width squared, however you want to refer to it as far as your formula. But it's going to be 12 by 12 because our square was 12 inches on one side, and we know that a square has all sides equal. So that gives me 144 square inches. Now to find the area formula for the circle, we know that the area is equal pi r squares, but we're not given the radius of the circle. What we're given is the diameter of the circle is the same as the sides of a square, because we said it's the largest possible circle is drawn inside the square. So to find the radius, we're going to take half of the diameter to get the radius. So the radius is now 6 inches. So I'm going to plug this into the area formula. Area is equal pi r squared. We get A is equal to 3.14 times 6 squared. When I do my calculations, I get 113.04 square inches. That's just the circle part. Now to find the area not covered by the circle, all I got to do is subtract them. So I take the area of the square minus the area of the circle, subtract them, and I get my 30.96 square inches is the amount that's in gray that you can kind of see outside the circle. So you may have to do a combination of problems. You may have to use one formula, then use another formula to finally get your final answer. So good luck on this section.